This is our class for artificial intelligence. We are going to be doing this class every Monday from 8 to 11, and I'm sorry that we are late today, but it's going to be fine. We are going to cover some content today. So it is good that you're here. So we can start off by looking at the course objectives and course outline. It is already shared in your portal. I already shared it in your portal. Kip Kirui, welcome to the class. And who else? Nicholas Kibot, welcome to the class. All right, so let me share the course outline so that we can all see it. And go through it even as we prepare to start the class. Okay, there it is. I hope you can see it. So the code for the unit is DSE 0501, DSE 0501. And those are my contacts. Those contacts are very important because we were going to be interacting a lot. So it is important that you have those contacts. The email is francis.mutuku@ztech.sc.ke. And the phone number is 0711-809-712. Now, this number, I am more available in WhatsApp for this number. WhatsApp. So WhatsApp will do just fine for this number. Sometimes you may find that I am off. Or sometimes you may find that I'm off for this number, but this number is always on in WhatsApp. All right, so you can use that number in WhatsApp anytime. I also expect that you create a WhatsApp group and add me so that we can also chat from there, so that whenever you have a query or any concern that you might be having, I can also see in the group, because I may not be able to respond to every private message personally. So as long as we are in a group, I can respond from there, and that will be fine. So basically, the course will introduce you to the things that have to do with artificial intelligence. You will have to understand the concepts of artificial intelligence, the approaches of artificial intelligence, and also the techniques of artificial intelligence. And at the end of the course, you as the learner, you'll be able to appreciate the benefits of artificial intelligence and how to integrate artificial intelligence into business processes, and how to use artificial intelligence in today's society, and also how to build some simple AI systems. So when I say AI is just artificial intelligence. So the unit is going to introduce you into basic concepts of artificial intelligence, and thereby you will be able now to build. You'll be able to know how AI is integrated in business and in IT. Then let's go to the course syllabus and the course outline. Chapter 1 is Introduction to Artificial Intelligence. Introduction to Artificial Intelligence. Chapter 2, in introduction, we have history of artificial intelligence, concepts associated to AI, types of intelligence, application areas of AI, and branches of AI. Then in chapter 2, we have intelligent agents. Intelligent agents. Under that, we have concepts of intelligent agents, types of intelligent agents, environments for intelligent agents, behavior for intelligent agents, and structure of intelligent agents. Then chapter 3, we will have problem solving. Here in problem solving, we have search algorithms and sort algorithms. Then chapter 4, we have knowledge representation. And here we are going to learn about the concepts associated to knowledge representation and representation schemes or representation formalisms. All right, and then chapter 5, we have machine learning. Under machine learning, we will learn some introductory concepts to machine learning. What is machine learning? How machines learn in their environment, learning by induction and inductive processes. Then the next chapter, we will have expert systems. Here we are going to study what are expert systems, types of expert systems, application areas of expert systems, and understanding how expert systems work, what we call the architecture of expert systems. Then the last chapter is general trends in artificial intelligence. So under that, we are going to learn about the modern trends of AI, the challenges of AI, and how to cope with the challenges of AI. So these are just basically 8 chapters, 7 chapters. These are 7 chapters. So they are not as short as you see them, because some of these chapters are very, very long and very detailed, like problem solving and knowledge representation, and also machine learning. These are very long topics. So you're going to find that the course outline may look small, but the content is actually a lot. All right. So how am I going to assess you? I'm going to assess you through 2 assignments, 2 cuts, and 1 final exam. 2 assignments, 2 cuts, and 1 final exam. So, of course, as you well know, the 2 assignments, each is awarded 5 marks. The 2 cuts, of course, 1 would be sitting and 1 cut take away, but we cannot have a sitting cut. So all of them are take away cuts, because you're at home, you can't be here. So so both of the cuts, each of them is 15, and so that gives you 15 plus 15, which is 30. And then the last final exam, which is theoretical in nature, is going to be awarded 60 marks. So 60 plus 30 is 90 plus 10, that is 100. The course itself is theoretical in nature. It is theoretical in nature, meaning that you're not going to be having any practical, but so it is entirely theoretical. So most of the time, I'm going to be sending you things like videos, which are going to help you to understand the concepts better. Videos from other tutors online that teach the concepts that I'm teaching, so that you can also look at them and their point of view. So that is what we have in the course outline. Some books you can use. There are some books you can use. The reference textbooks: Russell Stewart and Novik Peter, Artificial Intelligence: A Modern Approach, Upper Saddle River, Prentice Hill and Pearson Education, ISBN. That is the ISBN number. All right, and yes, so that is what we have for the course outline. That is what we are going to be studying this semester. That's what we are going to be studying this semester. So any question before we start? Any question before we start? I can see Juma, Vivian, you have joined us, Kimathi, Stacy, and yes, thanks for joining us. Any question before we move on? Any question before we move on? All right. Then let's move on to the coursework itself. Let's move on to the coursework itself. So introduction to artificial intelligence, that is chapter 1. Introduction to artificial intelligence. Now, the first thing to do is to define artificial intelligence. Now, intelligence is the ability to think and solve problems. Intelligence, it is the ability to think and solve problems. So when we talk about artificial intelligence, we are talking about a science that is involved in making systems that can imitate human intelligence. A science that involves making systems that can imitate human intelligence. So intelligence is basically the ability to think and to form problems. So for instance, if I tell you a plus x is equals to z, and then I tell you solve for z, the first thing you're going to look for is find the values for a and x. And then after you find the value for a and x, you're going to go ahead and add them or sum them up so that now you can get the value for z. Therefore, you're going to say z is equals to this. So what you have done, you have used available data, the values for a and x, which are those data, the available data. You have formed relationships, and those relationships are what? Summation, because a and z in this particular expression, they are related through addition. So you have identified the available data, and you have formed relationships, and then by joining the data and the relationships, you have come up with a solution. So what have you done? You have practiced intelligence. So intelligence is the ability to think and reason and form patterns or relationships, and thereby by doing that, you are able to do what? To solve problems. Basically, the idea behind intelligence is to solve problems. Or let's just talk about simple things like when I tell you go to Nairobi. So from that, you're going first, your mind is going to think, where is Nairobi? How can I go to Nairobi? You'll identify a bus. Where can I get a bus? You go to the bus station. How much fare am I going to pay? You go to M-Pesa and withdraw so that you cannot go into the bus without money. And then you identify a seat. After identifying a seat, the car starts. You keep watching how much distance is remaining for you to get to Nairobi. And then when you get to Nairobi, what do? You are light. All right. So what have you done? You have used the available data and the available knowledge that you have to solve a problem. Now, what is the problem? The problem is basically moving from destination A to destination Nairobi. That is the problem. So basically, all through, you have problems that you are solving. You have problems that you're solving, and these problems can vary from the simplest problems to the most complex problems. Like simple problems are things like how to call a phone, how to move from destination A to destination B, how to take lunch, how to take breakfast, how to take supper, how to eat. Those are simple problems. How to charge your phone, how to boot your computer, such things. So those are simple problems. But then there are complex problems like mathematical problems. There are dancing problems. For instance, if you are told to do professional dancing, you must be trained in that. If you are supposed to do a career, you must be trained. If you are supposed to program, to make programs, computer softwares, you must be trained. So those are more complex problems. So life is full of whatever you do in life is solving problems, and problems can vary from simple problems to complex problems. So intelligence is the ability to solve those problems. All right. So we can say that humans are intelligent. We can say that some animals are intelligent. So intelligence, all animals have intelligence, but and of course humans are the ones who have the higher IQ, the higher intelligence. Yeah. So intelligence, that the ability to solve problems, and you solve problems by doing what? You solve problems by reasoning, studying relationships between things, and solving patterns and therefore you are able to come up with solutions to problems. Okay, so artificial intelligence, so combine intelligence and artificial is something that is not natural, and intelligence is the ability to solve problems by thinking or reasoning. So what is artificial intelligence? Artificial intelligence is basically artificial systems that are able to mimic human intelligence, okay, or the science that is involved in building systems that are able to mimic human intelligence. So that is what artificial intelligence is about. Then let's move on to history of artificial intelligence. Now, where did artificial intelligence come from? Everything has a history. So artificial intelligence is not a very, very old concept, even though it has some old roots. But the first invention for artificial intelligence was in 1943. But even before that, there were technologies before that in the earlier civilizations of human beings. And earlier civilizations, we are talking about ancient Greek and such things, ancient Greek more so, that had technologies that had to do that. Now, ancient Greek, they used to have some technologies that were not really computer technologies, but they were stone technologies. Now, at your own time, you may look out for a movie called Stargate SG-1. Now, why am I proposing that movie? I'm proposing that movie because it explains a lot about ancient Greek and their technology. They used to have a technology, and this technology would help them to move from point A to point B and also to solve problems. So in Stargate SG-1, they feature this kind of technology where you can move between two quantum realities. Now, well, it is exaggerated in the movie, but the idea behind that movie is true. It is true that they had a technology that would help them to move from one point to another, but not between universes. That is not possible. But it would help them to move from point A to point B. It was like their own computer. All right, it was their own computer, which would help them to solve complex problems in life. So they started from there in ancient Greek, but the real computer journey for artificial intelligence began in 1943. Now, in 1943, this is where the first artificial intelligence idea was staged. It was staged. And it was staged by a man called Warren McCulloch and another man called Walter. And what they did is that they proposed a sample model. They proposed a model, just the same way you can think about something and you say, I have an idea. So they proposed a sample model for AI. And that sample model had something to do with artificial neurons. Now we are going to study about neural networks, but not now. We are going to study that when we get to another area, neural networks. But that was their first proposal. Then in 1949, a man called Donald Hebb demonstrated an updating rule for modifying the connection strength between neurons. So his rule, the rule to connect neural networks, up till now is being used, and it is called Hebbian learning. Hebbian as in Hebbian. So 1943, the idea was staged, and the idea was staged in form of artificial neurons or neural networks. Then in 1949, a model for joining those neural networks was made, and that model until now is called the Hebbian model. That was in 1949. Now these notes are they're in your portal, so you can find them from there. That's where I'm referring from. Then in 1950, there was a man called Alan Turing, and this guy is a guy that we're going to discuss even in the topic. We're going to go into the works of Alan Turing. There is something called a Turing Test that we are going to look at later in the topic. So Alan Turing is actually considered to be like the forefather of artificial intelligence, because of his contribution is more until now. It is being used until now in all areas of artificial intelligence. So what did Alan Turing introduce? Basically, Alan Turing was an English mathematician, and he pioneered the concept of machine learning, the ability of machines to learn without being programmed. And that was in 1950. And he published an article called Computing Machinery and Intelligence, and he proposed a test for artificial intelligent systems. Now, that test until today is called a Turing test, the Turing test. The Turing test is basically a test that was developed or proposed and developed by Alan Turing in 1950. And basically its concept is simply Turing test is helps in people that are in artificial intelligence to test the intelligence of a system, to test it, and they do it by testing it against a human user, okay, a human user and a system, and a computer system, and check which one is more intelligent. And you're going to see how Turing test works. All right. So in 1955, after Alan Turing, this set the stage now for most artificially intelligent systems to be made. Why? Because he developed a concept by which all intelligent systems are going to be tested, called the Turing test. So he is considered as the father of artificial intelligence, Alan Turing. So then now in 1955, Alan Newell and Herbert Simon created the first intelligent program, and it was called the Logic Theorist. Basically, the Logic Theorist was an intelligent mathematical system that was supposed to prove 38 mathematical theorems. The way you can say prove C is equals to SX plus Y, yeah? C is equals to MX plus Y, or Y is equals to MX plus C, something like that, prove. So the Logic Theorist was an intelligent system developed by Alan Newell and Herbert Simon that was supposed to prove 38 mathematical theorems, to prove 38 theorems, to prove whether it is true or false, and find elegant proofs for those theorems. Then in 1956, the word artificial intelligence was first adopted by American computer scientist John McCarthy at the Dartmouth Conference. And then for the first time, AI coined as an academic field. So all through from 1943 to 1955, we had what we call test performances. But in 1956, that was the first time that the term artificial intelligence was coined. And therefore, like any other science, artificial intelligence was introduced to be an area of learning, the way you can have mathematics or science or geography or chemistry, whatever kind of learning, computer science, such things. So artificial intelligence was introduced as an area of learning. So in 1956, through the Dartmouth Conference, artificial intelligence was the first time that term was used, artificial intelligence, and therefore now introduced as an area of learning. All right. So the golden years of artificial intelligence. So the golden years were when artificial intelligence really took shape, and this happened between 1966 and 1972. Those are the golden years. Sometimes people would say that it began between 1956 and 1974. 1956 is when AI was proposed. The term AI was began to be used from the Dartmouth Conference up to 1974. But other people consider the golden years of artificial intelligence to be from 1966 to 1972. Well, that is not the argument. That is not a worthy argument. Well, the idea is that the golden years of artificial intelligence is when artificial intelligence really took shape and was implemented in many systems. So in the year 1966, the researchers of AI emphasized developing algorithms. Algorithms are basically logical rules, okay? Logical rules or logical patterns. The way you can have algorithms for calculus, numerical linear algebra, such things. So they developed algorithms which can solve mathematical problems in 1966. So the first time when this was done, a man called Joseph Weizenbaum created the first chatbot in 1966, which was named ELIZA. Yeah, he created the first chatbot in 1966, which was named ELIZA. So ELIZA is there until now. I'm going to show you in my phone. It is in my phone, and you can also download it. Basically, ELIZA is a small, and I don't know why he chose to give it a female name, but ELIZA is a small program that is interactive. So how does ELIZA work? You just ask it a question and it answers you. Now, well, it doesn't have a lot of intelligence, because you will notice that sometimes it repeats its answers. But basically, you can ask it, how are you? It tells you, my name is ELIZA. How are you doing? It answers you. You ask it another question, it answers you, such thing. So ELIZA is there until now. So ELIZA is a chatbot. A chatbot is basically a program for one-on-one interaction between user and a system. And chatbots are there in websites. They are there. You can chat. Even Google has its own chatbot. You can ask it ask it questions. Websites have developed their own chatbots where you can interact with someone who can offer you online help. Now, that person is not a person. Yeah, I think sometimes you have gone into a website and then you have found a pop-up notification. Hi, I am so and so. How can I help you? Now, that one is not a person. It's just that's a chatbot. Okay, a chatbot is basically an interactive platform in a system between the user and the system itself. So the first chatbot to be developed, which the user can interact with, was called ELIZA, and it was developed in 1966. Now, ELIZA is still there until now. ELIZA is still there until now. I think I can show you. Let me show you ELIZA. ELIZA is basically a very simple app. So I don't know if you can see. Tap the microphone to speak or type at the prompt. So this is ELIZA, and I can actually speak to it. How are you, ELIZA? What is your name? What is your name? What is your name? I've told you before, I don't care about names. Please continue. You see? So it's just it's an interactive system that you can actually interact with. You can ask it questions and it answers you. It's called ELIZA. And you can actually download it. It's there in Google, in Play Store, whichever other platform you use to download apps. It's there. So ELIZA is a chatbot. Its work is just to interact with you. Okay. So this was built in 1966 by who? Joseph Weizenbaum. Then in 1972, the first intelligent humanoid robot was built in Japan. And this robot was called Wabot 1. Wabot 1. A humanoid robot is just a robot that looks like a human. That's what a humanoid robot is. So that means it has limbs, it has hands, it has legs, it has eyes. Yeah, it has all the sensory organs, or all the sensory systems of a human, the necessary sensory systems of a human. So 1972, that's when we had the first humanoid robot that was developed. All right, and robots are a very major area in artificial intelligence. Then from 1974 to 1980, we had what the historians of artificial intelligence, they call it the first AI winter. Now, what does the first AI winter involve? This is the time period where computer scientists dealt with a severe shortage of funding from government for AI researchers. Now, during AI winters, an interest of publicity on artificial intelligence was decreased. So AI winter is like the dark ages of artificial intelligence. Dark meaning the interest for artificial intelligence went down. For what reasons? We are not sure, but we can actually tell that some of the reasons, probably some of the reasons that were there were the concerns of AI, because AI has some disadvantages to people who may look at it critically. You may actually criticize AI for some reason, because we can ask ourselves questions like, can robots take over the world? Now, when we begin to think questions like that, we can actually go slow on how fast we are building AI intelligent systems. So the first AI winter was just AI winter. The period between 1974 to 1980 is referred to the AI winter. That is when most researches on artificial intelligence did not receive a lot of government funding, and also public attention for AI had gone low for reasons that we don't know. People lost their interest. But then in 1980 to 1987, this is considered the age of the boom of AI. The age of the boom of AI. So after that winter, what happened is that AI came back with expert systems. Now, expert systems were programs that emulate the decision-making ability of a human expert. Now, we already have a chapter called expert systems, so we are going to discuss expert systems in detail later. But in 1980, expert systems were made. Then also in 1980, the first national conference of the American Association of Artificial Intelligence was held at Stanford University. Now, why was this conference notable to the point that it was also recorded as part of the boom of the AI? Because it was from this conference that the interest for AI was aroused back in the public space. The interest for AI was aroused back, and also the concept of AI was explained again after the first conference before, which was done in 1966. So in 1980, the conference was held at Stanford University, now to bring to their attention, because now there was an AI winter. Public attention was gone. So they have to reintroduce it to the public. So they had to do a conference for that in 1980 called, and it was held at Stanford University in UK. Then again, there was a second AI winter. And second AI winter happened in 1987 to 1993. And again, we have said that AI winter is a time when there is not much AI activity being done, and also public attention for AI has gone low. So this time, investors and governments also stopped in funding for AI research due to high cost but inefficient results. And that always happens when you are starting something. You'll always input a lot of money in it, or a lot of time and attention to it, but it will give you less. Why? Because you are still learning. You're still taking off. Yeah, and it happens every time. It happens in business. It happens in wherever. It happens in relationships. Wherever a thing is new, it has its own pitfalls. It has its own rough areas. Yeah. So basically, the second AI winter, what resulted to this winter was not minimized public attention. It is that investors and the government could not fund anymore, because as they were funding, they were getting low results. And so it was like giving more for less. So that is not profit making. All right. So that is why that winter lasted that long, from 1987 to 1993. Those are 6 years. Then from 1993 to 2011, there was the emergence of intelligent agents. Now, there is a topic called intelligent agents, but I'll just basically introduce what an intelligent agent is. An intelligent agent is basically a system, whether software in nature or hard body in form, a system that is able to work intelligently. It can be a robot, it can be a software like a chatbot. So those are intelligent agents. So intelligent agents were now being built in 1993 to 2011. Now in 1997, IBM Deep Blue Beatswood world chess champion Garry Kasparov became the first computer to beat a world chess champion. So in 1997, there was the first computer that was built, and this computer, in it was integrated an intelligent program that could play chess with you. Right now, you have different games. You can download different games. Yeah, you can download different games. You can download pool. You can download motor racing. You can download car racing. You can download chess. For ladies, you like Candy Crush, so you can download those things. So and also you can download chess. So in 1997, the first chess program was developed. And it is said that this first chess program beat the then chess champion called Garry Kasparov. Garry Kasparov was a Russian. So that computer program beat that chess champion. So you can see how intelligent systems can become if they are built well. Then in 2002, a vacuum cleaner was developed. A vacuum cleaner was developed, which was intelligent. Then in 2006, now intelligence was incorporated into softwares, into other softwares. Like Facebook took up the challenge. Twitter became intelligent, and Netflix started also using AI, and other systems. In fact, even from around 2003 going on is now when we would have websites that have chatbots. You enter a website and then you have a notification area somewhere. It asks you, hi, my name is somebody, how can I help you? And then you can chat with it. It is not actually a person. It is a chatbot. It is an intelligent system integrated into the website. So in 2006, that is when now we had intelligence in computer systems like Facebook, Twitter, Netflix, whatever. So basically, the work of intelligence in these things is to basically the benefit of artificial intelligence is these systems like Facebook and Twitter is basically to avail data that is needed more easily. For instance, in Facebook, it is the intelligence incorporated into the program, the Facebook software, that allows you, when you are searching a name, it gives you a list of possible names before other names. So you can get the names that you want before other names appear. So you'll find that mostly the name that you want is basically at the top. It can search for that. Also, it can look for where you are, people that you have visited, notifications that you have not looked at, notifications that you have looked at, messages that you have not read, messages that you have read. You can also block people, and those people stay blocked. Those are just kinds of intelligence. Those are kinds of intelligence, and they're in Facebook, they're in Twitter, in Instagram, or in Twitter. Whenever you follow someone, it will give you a suggestion of other people that you find also relevant. For instance, if I follow a certain company, it will give me another company, a related company that I can follow. If I click follow, it will give me another related company that I can follow. Now that is a feature for intelligence. Now you see how that makes work easy, because it avails to the user data, relevant data that might be useful to the user, instead of the user searching for it too much. All right. And it happens in Twitter, it happens in Instagram and such things. Also in Netflix, it will show you the movies that have been watched. It will display for you the movies that have been watched frequently by other users in the world. It will show you the movies that you have watched yourself frequently. It will show you the movies that came up soon or recently. So those are concepts of AI. Okay, those are concepts of AI. So from 2011 to present, this is called the age of deep learning, big data, and artificial general intelligence. So you can see how many times we have broken that history, and it is in the notes. So from 2011 to present is where we have deep learning, big data, and artificial general intelligence. I think you have heard the term big data before, but if not, big data is basically the integration of complex data between systems. So for instance, Facebook uses data from Twitter. Twitter uses data from Facebook. Gmail, your Gmail account uses data from Facebook. Your Facebook uses data from your Gmail account. All this is called big data. These are data sets that are integrated together so that they can make intelligence easy. They can make the work of intelligence easy. It's called big data, the integration of a lot of data in different systems. So in the year 2011, 2012, 2014, and 2018, that is when we had a lot of machine learning being explored. You know, machine learning is a concept where you build systems which can think for themselves without being pre-programmed. So what you give it is what? Algorithms, patterns that it can use to think. And after you've given it algorithms, now it will be solving problems by expanding for itself that algorithm to fit more problems or to solve more problems. So big 2011 to present is when now machine learning was introduced in full force, and then the concept of big data and all that. All right, so why artificial intelligence? So we are done with the history of artificial intelligence. Why artificial intelligence, or what are the benefits of artificial intelligence? Now, number one, with the help of AI, you can create softwares that can solve real-world problems very easily and with accuracy, such as health issues, marketing, traffic issues, etc. So AI enables us to create softwares that can solve problems easily. Yeah, solve real-world problems easily. For instance, if you have chatbots for systems, a user, someone who visits that website will not find it difficult to solve some problems or to ask for inquiry. They can actually ask for inquiry for things they cannot understand, especially if it is a help system. If it is a help system, a system where a user gets in so that they can find products or serial numbers for products, or present inquiry for products they bought. So instead of going to their email account and typing and then sending that, you can interact with what? With the chatbot. And then they can connect you with an assistant, a person who can help you immediately, right? So it helps us to develop softwares or devices that can solve problems more easily. Then number two, with the help of AI, we can build robots which can work in an environment where survival of humans can be at risk. For instance, we can build robots that can go to space. Yeah, we can build robots that can work in manufacturing industries where there is a lot of heat. We can build robots for research purposes, like robots which we can send to places like Iceland so that they can perform researches and send data. Yeah, so we can build robots to be alternative humans, okay, so that they can work for humans in places where humans cannot otherwise work in because of the nature of those environments. And also AI opens a path for new opportunities and new technologies. And with AI, that is when now we can integrate with AI. Now we can have, as in, technology can grow better with AI. Why? Because we can connect devices. I think you have somehow you have heard the term Internet of Things, or IoT. Now, if you have not heard that term IoT is basically a concept that is associated with connecting devices to one another. It is a networking concept, like connecting phone to computer, connecting computer to your laundry machine, connecting your phone, your Android phone or your smartphone to your TV, connecting your smartphone to your car, connecting your smartphone to your coffee maker, connecting your smartphone to anything that is there that you have to use, connecting your smartphone to your gate so that you can open your gate using your smartphone, connecting your smartphone to your door, connecting your smartphone to your Gmail account. It's like you connect things to each other. So it's called Internet of Things. And that is a technology that could only come through artificial intelligence. It could never work without artificial intelligence. So AI has opened up a path for new technologies, and the latest technology that has been made through artificial intelligence, or has been made possible by artificial intelligence, what we call the IoT, the Internet of Things. Internet of Things. Now, what are some of the goals? The goals of AI. The goals of AI. Now, these are some of the main goals of AI. Number one, to replicate human intelligence. To replicate human intelligence. To replicate is to copy. So the main aim of artificial intelligence is basically to mimic how humans work or how humans reason, and to mimic that intelligence into a system. So is to replicate human intelligence. In other words, humans are the inspiration behind computers or in artificial intelligence. Humans are the inspiration. In other words, if I want a robot to work in an office environment, the reference point will be an office assistant who is a human. So I will see what an office assistant does, what are some of the questions an office assistant asks, what are some of the things an office assistant does, how does that office assistant do those things, how frequently does he do those things, how does he solve problems in the office, how does he pick papers, how does he receive calls, so things like that. And then I'm going to use that knowledge to build an intelligent system which mimics that. Okay, so and basically that is also the idea behind chatbots. When you go into a website and you find a notification, hi, my name is so and so, how can I help you? So you find that notification. Basically, the person who built that chatbot to work like a what? Like a contact person, or what we call a liaison person, somebody you can call on phone. But because it can be on an international line, you cannot call through international lines sometimes. So they just develop a chatbot where you can communicate with somebody and you can place your inquiries. All right. So basically, the main goal of AI is to replicate human intelligence. And then there are others. Number two, the other goal is solve knowledge-intensive tasks. Solve knowledge-intensive tasks. So basically, this is problem solving. Okay. Yeah, like mathematical problems, distance problems, and other problems. So solve knowledge-intensive tasks. Then number three, to integrate perception and action. Now, this is a term that I'm going to teach you more later, what is to perceive and what is to act. But just to introduce so that when you get there, you know it. To perceive is to think something, and to act is to solve a problem. Okay, right. So basically to create a connection between perception and action. Does that perception correspond to the action? If I ask Eliza, that app that I have shown you right now, if I ask Eliza, what is your name? Is it able to give me a relevant answer to my question? So that is what you call the relationship between perception and action. What has it had or input? What has it received as input? And how does it act through the input that I have given it? So that is called the relationship between perception and action. And then number four, build machines that can perform tasks that require human intelligence, like what? Proving a theorem, playing chess, even perform surgical operations, even drive a car in traffic. Yeah, you can actually search. There are self-driving cars. There is a company called Tesla. Tesla is right now being involved in the controversial 5G networks. I believe that you have heard 5G networks and the controversy behind it. Yeah, in UK, the public completely destroyed 5G radar whatever boosters because it is controversial. People think that it is connected somehow to the COVID-19. But that is just a conspiracy theory. Don't believe it. You are an IT person. You should not be an amateur. Don't go with the conspiracy theories that are going around there. So, 5G, Tesla, the guy behind Tesla, what's the name of that guy? He is so much involved in the 5G network. But basically, Tesla is a company that is developing cars, and it is known for its Elon Musk. Thanks, Juma. Elon Musk, yes. So this Tesla has built self-driving cars, and they have been there for a while. I think 5 to 7 years now. So so you see that in artificial intelligence has really paved the way for such interesting things. Yeah. So building machines that can perform tasks that require intelligence, like driving a car. So you just get into the car and the car drives itself. You just give it a destination. Yeah. And also create systems which can exhibit intelligent behavior and learn new things by itself. So those are some of the goals of artificial intelligence: to replicate human intelligence, to solve knowledge-intensive tasks, to create relationships between what a system perceives or input and how it acts, and then to create machines that can solve problems using human intelligence, and also to create systems that can exhibit intelligent behavior. And these are called expert systems. Okay. Any question up to that point? Any question up to that point? I think I have talked a lot. Any question up to that point? Okay, let me then continue. There's no question, and then at some point I'm going to call you to open your webcams at some point, but not now. At some point I'm going to require you to open your webcams. I'm going to tell you when to do that so that we can interact, so that I can see you. What comprises to artificial intelligence? What comprises to artificial intelligence? When we are talking about what comprises artificial intelligence, is what does artificial intelligence involve? What are the areas, the scientific area or the research areas that make artificial intelligence possible? Now, artificial intelligence is not just a computer thing. Artificial intelligence uses a lot of other research areas, and these are what is called the comprising areas. What comprises to artificial intelligence? Now, artificial intelligence uses knowledge from different disciplines or different research areas, such as mathematics, biology, psychology, sociology, computer science, which is the main one, neuron study, and statistics. So artificial intelligence uses, let me just share this document so that you can see what we have here. All right. Let me share that. Now you can see it. So artificial intelligence uses these areas. Artificial intelligence uses it borrows from these disciplines: mathematics, biology, psychology, sociology, computer science, neuron study, and statistics. Now, mathematics Mathematics is a discipline that involves creating algorithms and solving problems using algorithms. Algorithms are formulas or formulae. Yeah. So mathematics is a discipline that is very, very important in AI, because how is a robot able to do things like calculate distance? How is a robot able to do things like calculate uh, um, if it is a surgical robot, how is it able to measure how much blood is being transfused in milliliters? Yeah, things like that. Mathematics. And then biology. Biology is the study of the living systems of the world. So here we are talking about ecosystems, plants, animals. Yeah. Yeah. So psychology. So how is biology important? For instance, when you are creating a robot, a surgical robot, a robot that can perform surgeries, that robot must be able to understand how the human body functions. So it can know when pressure is going low, it can know when blood pressure is going up, and such things. So biology is the study of living systems. Psychology is the study of the mind, how people think. So this area is very important when you are creating robots that are interacting with people in the human space, how people think. For instance, you can have an office assistant, all right? An office assistant which is a humanoid robot. You can build that robot, but that robot must be able to know when the person or the manager who comes to the office comes in, how should he or she be greeted? How should he or she be asked questions? Yeah, how people think. And when the manager is thinking about something, the humanoid robot should be able to know, that the manager is thinking, and it would ask, what are you thinking about? How can I help you? So psychology is the study of how humans think. Then sociology is the study of how humans interact in their social spaces. Yeah, how they interact. Then computer science is the study of computers, hardware and software, and that is the main one. Why are we saying that computer science is the main discipline? Because AI cannot be integrated into walls. It cannot be integrated into wood. It cannot be integrated into other materials. It has to be integrated into hardware computer systems and software computer systems. Yeah. So artificial intelligence is a computer thing. So computer science is the main discipline. Then neuron study is the study of the mind, how the mind functions. And statistics is the study of things like probability, algebra, and such things. Statistics is a subfield of mathematics. So these are the research areas. And you can see how they look here. So unaona computer science has to deal with machines. Psychology has to deal with the human mind, how people think. Neuron science has to deal with the brain. I think you understand the difference between the mind and the brain. The mind is the brain is the organ. So neural networks are found in your brain. So psychology is how you think when it comes to different things. The neuron science or neurology, it's normally called neurology. Neurology is the study of the brain, the biological brain. Biology is the study of living beings, plants and animals. Philosophy is the study of what we call philosophy is basically things like history of man, history of things, social structures, and such things. Every area has its own philosophy. Yeah. So you can have a philosophy for science. You can have a philosophy for mathematics and such things. So mathematics has to do with things like addition, subtraction, division, multiplication, and such things. Sociology is the study of how humans interact in a social space or in a community. So those are the research areas of AI. Now, what are some of the advantages of AI? Through AI, we can build systems that are more accurate with less errors. Yeah. Through AI, we can build systems that are high speed. Through we can build systems that are more reliable. Reliable just has to do with accuracy. If a system has greater accuracy, then we say it is more reliable. Then AI helps us to build systems that can be used in risky areas. So risky areas where humans cannot explore, like when you want to send drones, yeah, you want to send drones high above, you want to send robots in the outer space where humans cannot otherwise exist, such things. Also digital assistants where you have chatbots. I think we talked about that before. Chatbots, interactive platforms in websites. And also AI is very, very good as a public utility. And this is where we have self-driving cars and such things. Yeah. What are some of the disadvantages of AI? AI has always been associated with high cost. Building an AI system is expensive. Building a humanoid robot is expensive. Building a website that has a chatbot is very expensive. So the AI has always been associated with high cost. Then also AI, we always say that AI can't think out of the box. In other words, AI is not creative. Now, this is where now humans beat robots. Humans, even if robots can work better than us and even with greater accuracy, robots cannot beat us in the area of creativity. That is why robots cannot think outside the box. They can only think from what they have been programmed and the algorithms they are using. They cannot be creative. If faced with new problems, they may not be able to come up with relevant solutions for those new problems. So they are not creative. There are things that require creativity and not learning, and you know those things. For instance, when you are trying to socialize with a new person, you don't need prior learning. You just need to follow what the new person is saying, and then you just follow through in the conversation and you chime in when your time comes. Yeah. So that is creativity that only humans can. Yeah. They can't think out of the box. Machines can't think out of the box. They only think by how they have been programmed or by existing knowledge that they have been induced with. Then robots or these systems, AI systems, don't have feelings or emotions. So that means that humans, again, we beat AI systems in this area. We have feelings and we have emotions. Now, these feelings and emotions, and of course, you know, ladies are more emotional than men, yes. Yeah. So I think ladies beat robots more than us. They have more feelings and more emotions. Anyway, so they can't feel. They can't feel. A robot cannot love. A robot cannot feel pain. All right. Things like heat can crumble a robot, but it cannot make it feel pain because it doesn't have what? It doesn't have feelings. It doesn't have emotions. It only works according to what it has been pre-programmed. So you cannot fall in love with a robot. A robot cannot cry. All right. So when you see these movies where they create robots that can cry, that one is not a reality that can be found. That is not a reality because robots cannot cry. They don't have feelings and emotions. They cannot feel you. They cannot connect to you emotionally. All right. They cannot feel you. Then also there is a disadvantage of increased dependency on machines. This has always been a fear that the more we create artificially intelligent systems, humans will become more reliable on them. And what will that do? That will make us to be more dependent on them, meaning that if they are removed, then we cannot work for ourselves. Can you imagine when, especially in the age of Internet of Things, where when you are at your workplace, you just use an app in your smartphone to ensure to check if kama ulizima taa kwa nyumba, you check kama ulizima taa na unaweza zimia kwa phone, you check whether you left the taps running, you can close them from your phone and such things. And or the most simplest, self-driving cars. Can you imagine self-driving cars? So that means that the more we use self-driving cars, the more we will not need drivers. That's right, yeah. The more we use self-driving cars, the more we will not need drivers. So what that will mean is that in 20 years of using self-driving cars, the knowledge for driving may go out of existence. Why? Because cars can drive themselves. So at emergency areas, or when, what will happen if we don't have self-driving cars? Then that means that we are stuck. All right, that means that we are stuck. We'll go back to Stone Age if anything happens to our systems, or we are crushed by a meteor, yeah, something like that. We go back to Stone Age because we have been overly dependent on these systems. Also, they make us lazy. They make us lazy. So AI systems make us lazy. We cannot calculate a lot. Because systems will calculate for us. We cannot search. We don't want to search a lot because systems will search for us. So they make us lazy, generally. And then also it reduces our human creativity. So, you know, when you have problems, the reason why, let me go back here. The reason why humans are creative is because there are problems to solve. You would not be creative if there are no problems to solve. The reason why there is creativity is because there are problems to solve. But if machines are solving these problems for us, it means that our intelligence, our ability to be creative and solve problems for ourselves also reduces. Yeah. So that is a disadvantage. The more you rely on something, the more you cannot think on your own. Okay. The more something thinks for you. It is like being a baby. It is like being babied for a long time by your parents. It gets to a point when you cannot think for yourself independently. Yeah. So what parents have to do, they have to release you, and you go and look for yourself. You go fend for yourself. You go look for a job for yourself. You go look for a house for yourself, and then you'll begin thinking. But as long as you stay with your mom, you're never going to be creative. You're not going to be imaginative. You are not going to be, because why? Because your mom is thinking for you. She's thinking how you're going to eat at night. She's thinking what you're going to eat. She's thinking how your laundry is going to be done. So your work is just to stay there. So you cannot be creative. You cannot be imaginative. All right. So that is also a disadvantage of AI. The more we depend on them, the more we lose our creativity. We cannot solve our problems. Do you remember that before calculators came, and now we have intelligent calculators? You can speak to it, and it gives you an answer. You just speak to it. You tell it, multiply for me this and this, and it multiplies. It gives you an answer on screen or on voice. Yeah. But before all these things came, our parents used to do what? They used to calculate without calculators. And we can actually say that our parents were the most intelligent. Why? Because they would calculate very big mathematical problems and come up with accurate solutions without calculators, without logbooks, logarithm books, and such things. So basically what we're saying is that artificial intelligence minimizes human creativity. The more systems think for us, the more we stop thinking for ourselves. And that is where now the fear for artificial intelligence comes in, because the more they think for us, the more we will depend on them. The more we depend on them, the more they will rule us. Yeah. And that is a fear, that the more we develop robots that are machine learning, they can learn us, they can learn our habits, the more they will rule us. They will know more about us. Somebody was saying that as humans are busy on social media, machines are busy learning. And that is true, because machines are basically, the thing about machine learning is that a machine, if you create a software system that can fetch data from the internet, that machine will fetch a lot of data more than a human. So a human will just be doing their social media things, but a machine will be learning, fetching data from different websites such that it learns more than you. Okay, so that is a very, very big disadvantage. That's a very, very big disadvantage. And yeah. So even before we go to the applications of the applications of AI, I want us to interact on some things about the things we've discussed, the benefits and the challenges of AI. And you can open up your webcams. You can open up your webcams so that we can interact on some things before we go to applications of AI. You can open up your webcams and so that I can hear you, so that you can ask questions. Anything that has interested you in the discussion that we have just had, so that you can also contribute. Yes. Or a question, or just something that you want to say. Yes, Saroni.
Yes.
Tell us something.
Yeah, I'm thinking about something.
What are you thinking about? Nderitu John, talk to us. Tell us whatever you've learned. What have you learned so far? What have you learned so far, or what do you think you will want to learn as we continue? What do you think will interest you in this area of artificial intelligence? What are you eager to learn? Anybody who can hear, you can just tell us, what are you eager to learn in the unit? What are you eager to learn? What are some of the things you have faced in real life that you think, this one can be something to do with artificial intelligence? I may want to know more about it in the unit. Just share with us, anyone. Yes.
Yes. Good morning.
Good morning to you.
I was asking, how is data science related to artificial intelligence? Because I've seen a lot of cross references between the two.
Yeah. So this is Saruni, or this John?
John.
Okay.
Yeah.
So, John, data science is a field that is related to big data. Big data is basically the connection of or interconnecting data from different systems so that there can be relationships. So data science is completely involved, and data science is a major area in artificial intelligence. And normally you read about data science at especially when you go to the master's level. There is also mathematics to data science. There is mathematics, the mathematics of data. So the mathematics of data is a very big area in artificial intelligence, and it is yes, it is related to artificial intelligence in total. Yeah, it is an area of artificial intelligence.
So you highly recommend for people to think about data science because it is one of the most upcoming field in IT.
Data science, yeah, data science you are going to, and there is actually a field called data analytics.
Yeah.
yeah, data science and data analytics, you can think about it as you think about AI. These are very, they are very good areas. They
Data
are very
engineering
good.
also.
Yes. So anything to do with data, the mathematics of data, it is a rich
Yeah.
area that you can explore,
Yeah.
and it gives you a lot of knowledge on how AI systems are built.
Okay.
Yeah.
Thank you. Thank you. I was having a challenge connecting the two, but now I understand.
Yeah, they are just data science, data engineering, and data analytics. Those are just segments of the same area that are related to dealing with big data and interconnecting data to systems so that systems can fetch data more easily. Okay.
Nice. Yeah.
Yeah, so they
Thank
are
you.
related, completely related. Yeah.
Thank you, sir.
All right. Anyone else? Anything that you are learning, anything that you have learned so far that you might want to share, or something that you are eager to learn about, you've found in real life, and you think that it could be an area that you may want to know about as we continue the unit? Anything? Have you interacted with any intelligent systems uh, in your life? Have you interacted with any intelligent systems? Are there things that you can share with us about your experiences of intelligent systems? What were some of the advantages that you got from interacting with those intelligent systems? Some of the disadvantages that you got from interacting with those intelligent systems? You can share with us. Have you interacted with any chatbots before? A chatbot, ChatBots. Chatbots. Have you interacted with chatbots before? How did you find them? Which website did you visit? Things like that. How have you experienced computer intelligence in your life? In as you deal with computers.
For me personally, maybe through universal package drivers,
Mm-hmm.
where the moment when they were installing the all the drivers, there was this. I think there was this. Okay, there was this. I don't know if it was a person, but I think it's a robot. It was talking, and I could answer, and then it was like an interactive session, but it kept
Uh-huh.
repeating some of the few things though.
Uh-huh.
Yeah, so like for an instance, I asked it if how long it will take to install the drivers. It said approximately 30 minutes and 6 seconds.
Mm-hmm.
Later I asked it how long it will like it will take to update the drivers after installing them.
Mm.
So it also said the same time, but though it was not very very precise, but it was a good
Mm-hmm.
system. Yeah,
Mm.
it was
Thanks.
a good system.
Yeah, that is actually an example of in artificial intelligence. That's called a chatbot. Whenever you have an interactive system integrated inside a website, that is normally called a chatbot. So you can ask it questions, you can send an inquiry, and it gives you answers. Normally, chatbots are not very precise, but the precision of chatbots increase as more users use it. Okay,
Yeah,
because artificially intelligent systems use data. They use what is called knowledge. Knowledge is data. So for them to
yeah.
be more accurate, they have to deal with more data, more knowledge. It's just the same like a human. For you to be able to solve more complex problems, you should have gone through more learning, or more fetching more data, gathering more data.
Ah,
So yes, chatbots also work that way. The more the users use them, that is why every time when you visit a website, always chatbots are there, kind of enticing you to interact with it. Why? Because the more the human users interact with chatbots, the more those chatbots become intelligent. Because you see, when you ask it a question, another user will ask it a related question. So millions of users will keep asking it questions, but some of these questions are very related. So it will be able with time to generate new answers which are more accurate. Can you see that?
Yeah.
Yeah.
So you're
So
saying,
yeah.
For these systems to gather data, they get data through social engineering, where us as users feed them data
Yes.
through the internet also. Those ways.
Yes, they gather data through human users and also other websites. So if you have to integrate it, if you have to provide Gmail, if you have to provide your Gmail account or your Gmail or connect it, connect yourself to that website using Facebook. There's a time when you have to, like, for you to visit that website, when you are registering, instead of now registering, manually or from start, you register from Facebook. You log in with Facebook account, right?
Yeah.
So it fetches data, some of the relevant data, not much of the personal data, but some of the relevant data from that site, so that now it can integrate that data for problem solving. And also you, the user, and other users as they keep interacting with the system, their data is being generated. It's kind of more data. It receives more data from people. And so the more data it has, the more it is able to solve problems. Then there is Kimorota Dennis, who is saying, yes, I have used chatbots before. Like in Telegram, I used two chatbots, one Lydia and another called Mitsuku. Mitsuku, one most intelligent Telegram chatbots, and for real, when you chat with it, you see its intelligence is quite high. Even at some point shows sarcasm and takes on dark humor. Wow, that is good. I've actually not interacted with Lydia and Mitsuku, but that is a good one to hear. I think now I'll go and search for it. Yeah. So thank you, Kimorota, for your contribution. Yes. In fact, by the way, if you have an intelligent system that can actually take jokes or sarcasm, that is a highly intelligent system. Actually, that is a highly intelligent system. For a system because systems normally deal with basic data. They cannot generate what is called creative data. Creative data is data that you generate from creative data are things to do with emotional data, things to do with sarcastic data and jokes, such things. Those are creative data only humans can achieve. So if you find a system that can actually generate creative data, that is a system that is highly intelligent. Yeah. There is Rose 2 in Telegram. Rose in Telegram. That is good. I can see you've actually interacted with most of these. Where are the ladies? Vivian, Kimathi, Stacy. I need a contribution from some of the ladies. Vivian, Kimathi, Stacy.
Maybe before they ask,
Yes.
how are because for this intelligent system, I've been following up these ads about self-driving cars. They have like hundreds of sensors built in them.
Yes.
I was asking, how are sensors built? Is it through the normal programming languages, or there's a different level of skills that you're supposed to have?
It is the normal programming languages. Now we are going to discuss sensory abilities of artificial intelligence system when we get to chapter 3 called intelligent agents. We are going to discuss that better, and we are going to be discussing how intelligent systems can sense the environment. Like a car can sense another car coming and it can accelerate or decelerate. A car can sense when another car is overtaking and it can decelerate. A car can sense that there is a barrier and it can decelerate. It can brake. It can light up. It can open up the lights when it is nighttime, when it is dark. It can sense all these things. It can also sense touch or impact, which could mean that there is a possible accident. So it can sense impact. So cars can also have those sensory activities. So we are going to discuss more of that when we get to intelligent agents. So that is a very, very good observation. Yeah, there is a manner in which intelligent agents interact with their system, and they receive from their system things we call percepts. A percept is an input. An input can be in form of sound. It can be in form of data that you type into it. Like, for instance, in the case of chatbots, but in the case of robots, they can hear sound, they can feel heat, they can feel the temperature rising or temperature lowering. A simple example is the thermostat, the intelligent thermostat. The thermostat, whose basic work is just to regulate the temperature of a room. All right. So basically, what it does, it feels the temperature rise and then it goes low. When the temperature goes too low than the normal, it heightens the temperature. So intelligent agents, these systems are able to actually feel their environment and they are able to respond. So that is an area that we are going to actually deal with, or we are going to discuss more when we get into the topic intelligent agents.
Okay.
Yeah. I can see Nicholas Kibiwot, you've interacted with Zuri from Safaricom. Yeah, thank you. Yeah. Which you can also tell us your experience from Zuri. You can just type in there, or you can tell us by video or audio. Nicholas Kibiwot, just tell us your experience using Zuri. Juma, Vivian, I have only interacted with the Netflix chatbots. How was your experience, Juma? Could you please tell us? Thanks for that. Timorota Dennis, my phone runs on an AI Jarvis, which reduces a lot of work. I'd have done typing and taking on notes, calling, and it does a lot of active calling, active talking. Oh, thank you, Kimorata Dennis. Good. So in fact, it's good that you have told us, Kimorata Dennis, the kind of what you are experiencing with Jarvis, that it has reduced a lot of work on your end. You don't have to do a lot of typing. Also, you don't have to do you don't have to do a lot of typing. So you just tell it what you need to do. I think all of you also, you have interacted with Google chatbot, where you don't have to type what you are searching. You can just tell Google what you want and it tells you. Yeah. Kimathi Stacy, yes, I've interacted with an AI. Its name was Orca. It's a companion robot. It builds its knowledge from what you feed it, exactly what we were talking about, that chatbots and all interactive systems build knowledge from data. The more you give it data, the more it can respond to you. Yeah, so it builds its knowledge from what you feed it. The first day it asks some personal questions to get to know me. Then the next day it uses the knowledge acquired to ask more questions. Good, good. I think now you can actually learn from each other. Some people have used Rose, some people have used Siri, some people have used Zuri, Netflix chatbots. Some people have used Jarvis on their phones. Others have used Orca, which is able to build on your personal profile, and it is able to interact from your personal profile. Juma Vivian, the Netflix chatbot is also intelligent because it has humor and has a lot of information on movies. Thank you. Yes, that is true. And you can also actually search the movies that have come recently, or they have been watched a lot. You can actually search them. Yeah, yeah. They actually recommend for you. So any system that recommends for you relevant things, it recommends. You can search this, you can search this, you can search this. That is an intelligent system. Yeah. Also, all of you, I think you've interacted with Jumia or Kilimall. Anytime you search for a product, it will recommend for you other relevant products. Yeah. Yeah, it actually recommends for you other relevant products that you can actually search for. Yeah, so these things are fair. Mwangi Jefferson, there are people who are not talking here. Mwangi, Nicholas Keyboard. For Zuri, I had a problem with my network, so texted Safaricom in Facebook and they recommended Zuri. It works just like customer care. It responds quite well. Ah, thank you. Yes. Yeah, that's what I wanted, how you found it to be. So it's just a chatbot for giving inquiries where you can also receive answers immediately. And you see, the good thing about chatbots is that you don't have to email a company about your needs, because companies, as companies run their operations, they have a lot of data to handle. So somebody may not reply to your email soon, but using a chatbot may help you on one-on-one, and other things that you may need, it can actually recommend, or it can connect you to an assistant. So those are good things. Yeah, thanks, Nicholas. Nuri Hamza, Facebook Messenger bot. Thank you. Nicholas Keyboard says you cannot compare it with Siri. What is the difference between Zuri and Siri? Probably you can tell us, Nicholas. Siri is on another level. Mwangi Jefferson mostly use Google Chatbot. Yeah, thanks. And that is actually very, very common, Google Chatbot, and it's very, very effective. Google Chatbot is very effective. And also the thing about chatbots is that they are chatbots are also good for people who are blind, for people who cannot type. Of course, people who cannot type can actually, there are blind people who can type, but not all. So you can actually talk to it, you can search, yeah, and it can talk back to you. Chatbots are very, very common. They are very, very common types of intelligence systems out there. And I don't think these days a company may release a website that doesn't have a chatbot, not unless it's a blog, all right? Not unless it's a blog, a personal blog which you are creating just to interact with people. They read your things and they reply. But if it's a website which is a commercial, an intensively commercial websites where you are dealing with clientele, there are customers you have to interact with from day to day, a chatbot will be necessary. And normally you just use Python. Python is a very powerful language to create intelligent systems. Python. Well, I'm not very good in Python. There are teachers who are good in Python, but Python is very good. Java, I will teach you. I taught. Did I? No, I didn't teach you. But Java is for building. What we call graphical user interfaces. But Python is good for building intelligent systems. But if you want a good graphical user interface, Java is the thing. So using Python, you can build chatbots. You can build websites and websites that have chatbots and all that. Yeah. Nicholas Kibiwot. Zuri is more of customer care, but Siri is quite advanced. It's from Apple. Siri can play music, make calls, etc., just from your voice commands. That is good. That is good. Thanks for bringing in that distinction. Now we can know what the difference is. So Zuri is for customer care, but Siri is more interactive for your phone, for doing things with your phone. You can set alarms, you can play music, you can open file manager, you can open gallery, you can open WhatsApp and type a message and such things. Yeah. Mwangi Jefferson, the new auto cars have a chatbot connected via your phone. E.g., I used my parent car to connect with my phone. I call or ask a maps direction, or I think you meant you can call or ask it for map directions. That is, yeah, that is true. Chatbots for cars, interactive platforms for cars where you can even talk to your car. You can ask your car how much fuel it needs. Yeah, there are those cars that have those interactive systems that are such advanced. Yeah, but basically the basic chatbots for cars is for asking direction. maps. How far am I from destination B? You know, yeah. So that is good, Mwangi Jefferson. Yeah. Yeah, so I think now you've all interacted and you've shown some kind of way that you have interacted with this system. So that is very good, that you have actually, from what we have learned now, you have known, you can apply what you have learned just now to what you've interacted with in life, to know that actually this is what has been happening. So that is good. So now let me share this screen here so that we can continue with our work, with our coursework. All right, let's see. Let me share this. Okay. Application areas of AI. This is an area that we can actually discuss, but just because we've just discussed, we've already discussed right now. In fact, we've already discussed right now chatbots of cars, chatbots in customer care like Zuri, chatbots for using your phone better or more efficiently like Siri. People have talked about Netflix chatbot. People have talked about Google chatbot. People have talked about self-driving cars for chatbots for self-driving cars, Orca. People have talked about Jarvis. Yeah, so those are application areas. So when you ask what are some of the application areas, those are exactly the application areas you should be talking about. Yeah, but of course there are other areas probably we can look at from these notes, like AI in astronomy. How is AI in astronomy? How does AI play out in astronomy? In research, in astronomical research, like sending robots to which can explore unexplored universes or unexplored planets like Mars. So you send robots there. It's actually said that, and I can actually search for this. Let me just search for it here right now. That NASA sent an intelligent robot in 1972 to explore the universe, and they sent it, and it never came back. Well, of course, that was the idea. They sent it so that it can go far, so that it can send NASA data on the nature of our universe. Let me search this for you. Let's see this. So in 2008, they sent some robots to the moon. In 2011, they sent some other robots. And also in 2020, NASA will send living things to deep space for the first time, but that is not artificial intelligence, right? But basically, the idea here is that AI is used in astronomy, where robots are sent out to explore unexplored universes or unexplored planets, so that they can research and they can send back feedback or data. Then there is also AI in healthcare, things like robotic surgeons, robotic diagnosis systems and such things. Then there is AI in gaming, like you can play chess. There are intelligent games, computer games, like there are intelligent chess games, there are intelligent wrestling games, there are intelligent other games, pool games that are intelligent, that you can actually play with it and feel as though you are playing with a fellow competitor. Then there is AI in finance, and this is very, very, very important, especially when you are dealing with things like loans. When you are dealing with things like loans, normally these days, that's why they can actually follow you up. They can actually follow you up in CRB. Yeah, they can follow you up in CRB. Yeah, in why? Because most of your data is interconnected. Financial institutions where you have taken data, where you have taken money and such things, it's you can actually they can actually trace you. Financial institutions, they can actually trace you. So if you borrow loans from this company, you borrow another loan from this company, you borrow another loan from this company, they can actually trace you. So financial institutions also use big data to follow up on their customers. Then there is also AI in data security. AI in data security, where we can implement protection of data, what we call cyber security, so that our websites can be secure from hacking and such things. Right. Then AI in social media, like in Facebook and Twitter and Snapchat and Instagram and such things. AI in travel and transport. This is where we are talking about self-driving cars. Yeah. AI in automotive industry. AI in automotive industry. AI in robotics. Automotive industry is basically, we were talking about cars, Tesla, yeah, and things like that, and Tesla bot. So Tesla bot is basically what? It's a chatbot for Tesla cars, where you can interact with that car, yeah, things that are related to that car. Yeah, so it's like a chatbot for Tesla. It's called Tesla bot. Then AI in robotics, that is basically the building of humanoid robots. Yeah. Then AI in entertainment, things like Netflix, Amazon, and some of you have mentioned Netflix bot, where Netflix, they have their own chatbot. Yeah. Amazon and such things where it can recommend for you TV shows or programs. Then there is AI in agriculture. How do we do this? AI in agriculture is comes in where we have scientific analysis of soil, scientific analysis of climatic conditions, scientific analysis of harvest, also to determine, to kind of calculate and predict how much harvest is going to be gotten after a particular period of time, given that resource A, resource B, resource C is provided. How much output or how much harvest, how many bags of maize are we expecting to need? So even people can plan. So farmers can even plan on how much profit they are going to get even before they actually get the profit, or even before they harvest. It's kind of counting the chicks before they hatch, which always works most of the time, because as long as all these factors are constant, you can actually calculate if the soil pH remains this, and the water levels remains this, and the rainfall patterns remains this, then it can predict that you can actually get 90 bags of maize or 93 bags of maize. Yeah. Then AI in e-commerce, like in Jumia, when you buy a product from a company, it will suggest for you products from other companies or similar products or related products from similar company or related companies, which you can also look at and purchase. Then there is AI in education. There are chatbots that can help you as teaching assistants, virtual tutors, yeah, and such things. Yes. So AI is implemented in different areas, and those are the very things that we have talked about. Now, Kimathi Stacy asks, what is the role of nanotechnology in AI? What is the role of nanotechnology in AI? Who can answer us that question? What is microtechnology and nanotechnology? What is the difference between microtechnology and nanotechnology? I know it's something that probably you have heard in movies or some things, some of those platforms. What is the difference between microtechnology and nanotechnology? Microtechnology and nanotechnology. Now, microtechnology is basically the use of what we call micro PCs. Micro PCs are things like desktop computers, laptop computers, and tablets, and also smartphones. So when you are dealing with microtechnology, we are dealing with microcomputers. When you are looking at when you were studying about introduction to ICT or introduction to computers, you study the classification of computers, and the classification according to physical size and processing power. You studied microcomputers, supercomputers, mainframe, mini computers, microcomputers. So microcomputers are the computers that have less processing power than mainframe, mini, and super, and their processors are called microprocessors. So like your smartphone is a microcomputer because it uses a microprocessor. So nano computers are basically computers whose processor is smaller than a microprocessor. So that means nanotechnology deals with things like implants, implants on human bodies or animal bodies. That is what we call nanocomputers. So nanotechnology has everything to do with processors that are small enough to be integrated into the smallest of systems without being detected or without you feeling. Okay, so you can have an implant of a chip, a nano chip. You can have nanochips in your eyes. And nanotechnology is actually being used right now in researching how blind people can receive back sight. So nanotechnology is a very, very powerful technology. It is also connected to artificial intelligence, but not as such. It is not as such. It is not so much connected to artificial intelligence. Nanotechnology, basically, it is a technology that is helping people. Now we have Internet of Things. Now, in the future or in ongoing future, we are going to be having Internet of Things and people, where we can connect people to computers. Now, right now, we can, human users can interact with a computer in the normal way. You type data or you ask a computer question. But there is going to be a time when you will have computers implanted into your brain. I don't know if it will come that time, implanted into your brain or implanted into your body. So nanotechnology is that, where you have computer implants or processor implants into your body or in other areas. So it is not necessarily related to AI. It is just a technology that facilitates how computers can be integrated to humans. Yeah, just that. Anyone else who wants to contribute? So nanotechnology does not necessarily have to do with AI. It can be integrated with data. If it is integrated with data from where it can form relationships and solve problems, then we can say that it uses AI concepts. But at its basic level, nanotechnology is basically a technology for having small, invisible, quote unquote, invisible computer processors. And this helps to implant on people, on things, and such things like that. Mwangi Jefferson asks, what about the chip installed in people's hands in Sydney? Is it nano? Yes, that is nanotechnology. And also this one is also being used in Japan. They are using it in Japan for their train transport. So instead of you paying fare, there is a microchip that is implanted onto your hand, and especially it's normally your hand, that is implanted into your hand that has all your details. So now that is where now we say that when it is integrated with all your details or data, that is when now the whole concept of artificial intelligence comes in. Are we together? Yeah. So when they integrate it with data, then it becomes an AI system. So yes, so you get a microchip and you are able to pay your fare and such things. So when you get into the train, you can do that. You can pay your fare. You can go to a place, you can pay for it. You don't have to carry your MasterCard. So now when Mwangi Jefferson, so when now nanotechnology has been integrated with human data, is when now we can say that nanotechnology has some form of intelligence. Otherwise, at its basic level, it doesn't have intelligence. And Kimathi asks, there was this article from MIT that talked about nanotech and how they are using them to gather information about patients' health. The information is then directly sent to their doctors to give out medications. Exactly. And that is now where AI plays in. Again, I say that when nanotechnology is integrated with data is when now it becomes intelligent. But at its basic level, it doesn't have any intelligence. Are we together? Yeah. So when we have, like Kimathi has pointed out, MIT, their research area for nanotechnology that can integrate patients' data, then now we can say that that technology, that nanotechnology, has some artificial intelligence ability to it. Is Arduino in any way related to AI? Now, Arduino, for those who may not know Arduino, Nicholas Kibiwot, Arduino is, for the rest of the class, Arduino is basically a system that is able to, it's normally used by electronic engineers. Its work is basically to build electronic systems. Now, it is like Arduino is like a programming, it's like a programming for engineers, okay? Programming for engineers. Is it related to AI? Yes, if it is integrated with data. But if it is not integrated with data, then at its basic level is not AI, okay? Yeah, so anything, any system becomes AI enabled if it is integrated with data. But any computer technology at its basic level, if it is not integrated with any data, it is not yet an AI system, because AI systems work on data. Okay, so we cannot have an AI system without data. It will just be another computer. Yeah, just like a laptop. Yeah, it's just another computer with storage sites and a processor and other things. But for it to be AI enabled, it has to deal with data, and from that data, it can study relationships and also solve problems. So Kimathi, Stacy, when that nanotech has been integrated with patients' data and it can directly send them to doctors to give out medications, then it is then what? An AI-enabled system. Arduino, it is not in any way related to AI, unless, you know, Arduino is like a platform. The way I can use code blocks to code, okay? The way I can use what else? NetBeans to code. The way I can use whatever platform, other IDE to code. So Arduino is just a coding platform for electronic engineers. So it is not, these frameworks for coding, they are not AI related. But if I build a system with it and integrate data to that system, then it makes it what? An AI enabled system. Yeah. Okay.
Okay, sir.
Yes.
So they have also said that in micro technology,
Yes.
they use a top down approach, and in nano they use a bottom up approach to fabrication. So what does that mean?
Top down approach.
Yeah,
yes.
For the micro.
Now, do you remember when we were studying what? When we were studying, what was this? Object-oriented analysis and design.
Yeah.
Now, in object-oriented analysis and design, the way to break down a problem, a bigger problem, to a smaller problem is what we call the top-down approach. Okay? The way you break a bigger problem to a smaller problem. The way you can have, we want a system for M-Pesa, but M-Pesa will have different modules in it. So you can break M-Pesa into different modules. And in this module, you can have send money. This is going to be withdraw money. This is going to be buy airtime. This is going to be Mshwari or loans, something like that. Now, also at withdraw money, you break down this problem into more simpler units. Okay, in by airtime, you break down this problem into more simpler units, which you can code for. So after now, you group all these things into classes. You remember in object-oriented programming, you group every code segment into classes, and then now all these classes you combine them together now to form what we now call the M-Pesa system or the general system. So top-down approach is where you break a bigger problem into a smaller problem. Okay.
Okay.
But in bottom-up approach is where you begin with the smaller problems in order to form a bigger solution. So this is how it works. In top-down approach, you don't know how the smaller systems work. You only know how the bigger systems work. Are we together?
Yes.
So you come from the bigger system, which you already know how it works, then you try and form smaller systems that work independently. But all these subsystems have to work together in a manner in which they fulfill the general objectives of the bigger problem. But now, in bottom-up approach is where you do not know how the bigger system works, but you have an idea of how some small systems can work. So in bottom-down approach is where creativity is built from down up. So you get systems, you know how these smaller systems will work, you interconnect them together, and you continue interconnecting them together as you move down up to the bigger solution or the bigger framework. So basically, top down is where you break a bigger problem to smaller problems. Bottom up is where you begin from the simpler solutions and you create the more general solutions. So the simpler solutions will be serving the more general solutions. So that is basically it, and it is normally in object-oriented analysis and design. It is in system analysis and design, and it is also in microtechnology and nanotechnology. Now, why does microtechnology use a top-down approach? Because a top-down approach is simpler and it is not processor intensive. Are we together? A top-down approach is not processor intensive. Why? Because we just have to know the bigger problem, and then now we can develop smaller systems. So it is not processor intensive. Again, always when you look at the word, when you look at that term, you look at that term top-down approach. Top-down approach, one thing that is related to top-down approach is its simplicity. Its simplicity. It is like building a house. Building a house, you already have the format of the house. You can have the architectural plan. So you have the plan. So it becomes very easy to implement the plan. Okay. But in bottom-up approach, you do not have a plan. In other words, microtechnology, you need to have a bigger, you need to have a, it needs a simpler approach. Simply, that is what I'm saying. It needs a simpler approach. Why? Because microtechnology is, you know, bottom up is processor intensive. Why? Because bottom up first gathers the data and then comes up with a solution. Okay. But top up approach, it first has the solution and then creates the data, and those data, they are called data subsets. Okay. And those now data subsets are going to work together to form the general solution. And therefore, it is not processor intensive. So basically, top-down approach is simpler and it is not processor intensive. But nanotechnology uses bottom-up because bottom-up comes up with more accurate solutions which can expand over time. There is something in computing we call scalability. Scalability is the ability to enhance a system by adding new features or reducing the features that have been there. So you cannot work with scalability when you use bottom-up approach. I mean top-down approach. Why? Kwa sababu ni kama kujenga nyumba. Whenever you build a house, you already have the bigger house, or you already have the plan. Okay, you already have the plan. So that plan, you just implement it. Now, next time when you want to expand that house, it may not be possible. Kwa nini? Kwa sababu kama ni foundation ulikuwa umeweka kiasi fulani, so you cannot go further up. You can only go probably 2 floors or 3 floors. You cannot scale much. If you want to connect another room, you may not be able to build another room and connect it to the existing wall, because the existing wall will make when you break the existing wall, the house will be weaker, because in the general plan, it was set to be that way. The strengths were already determined. So on a top-down approach, it's a simplistic approach. It does not allow scalability. Okay, it does not allow scalability or increasing the system. But bottom-up approach, it allows scalability. The system can be increased. That is why by using nanotech, we are able to integrate more data with time, and it will not crumble the system. Are we together? It will not crumble the system, because nanotechnology is dependent on building from bottom up. It does not have a general solution. The more you give it data, the more intelligent it becomes. Okay, so that is the difference between top up and bottom down.
Okay, thank you. I have understood.
Yeah. All right. So top down, bottom up. Okay. All right. So types of artificial intelligence. Here we are back to these notes. Oh, and by the way, our time is over. Yes. I think our time is over. It looks as if our time is actually over. Now let's continue from there. Next time we are going to the types of intelligence, because it's already time. It's 11. Yeah.
Yeah.
Before we go, I have a small question.
Yes.
You've said for a system to be called an artificial intelligence system,
Yeah.
it has to have data incorporated into it.
Yes.
Right? And how are you able to add data into the system? You remember that system that you told us to draw an object class diagram, the one about a hotel application where you come book. How can you make that system an artificial intelligence system?
How can you make it intelligent?
Yeah.
Now, you work with what we call sample data. Now, at our level of artificial intelligence, as we study this unit, we are not going to go so much into how to practically integrate data into systems, but we normally use what we call sample data. Now, sample data, you as a programmer, you just type that data in it. For instance, kama ni mathematical data, you type those values. X, unaweka variables za X, variables za Y, variables za Z, una set arrays, una set stacks, binary trees, unazicode. So basically, the way to enter data into a program is to basically to code it. When you code it, you avail the necessary data, the relevant data, the variables. So you have variables, you have data structures like arrays, trees, stacks. So you just give it sample data and algorithms. An algorithm is a formula that system is going to use to manipulate that data. So you are also going to code a section of the program which is going to be allowing the program to be fetching data from users. Are we together? So whenever the user is giving that system input, the program should have a way of receiving that input, those inputs, and integrating it into the data. So ni kama hii data ina grow. Are we together? So unaanza na sample data. Sample data ni basic data, like variables. Unaweka the value for x is equals to 10, y ni 12, na z ni 13. Yeah? And then unaweka arrays. Unasema hii array itakuwa ya kuchukua inputs za user. Then hii star kama hii binary tree itakuwa ya kuchukua other inputs of this nature. So these data sets will be growing as the program is being used in real life. It will be growing. But what will not grow is the algorithm. Algorithm is a static formula, a formula that cannot change. It's like y is equals to mx plus c. So itakuwa inachukua the possible values for m, the possible values for x as the user interacts with it, the possible values for y, for c, and all these values as it receives those values, it keeps computing for y in every case. So unaipea sample data, and how to do that ni kuicode na ni declare two variables. Okay, you declare variables. Yeah.
Okay.
Yeah. All right, I think we can stop at that. Anyone else with another question?
I think for me, I'm good.
Okay. Mwangi, are you fine? Nicholas, Kibiwot, Kimathi, Kimorata, Dennis, Juma, Vivian, Edmond, Nuri Hamza. Tuko sawa? Thank you, Nicholas. Thank you, Kimorata. Okay, Kimathi. So we are not going to do this practically. Unfortunately, no. Unfortunately, no. But if at any point you are going to do any programming in Python, you are going to study AI practically. But for this unit, it is all, it's an introductory unit. It is not a unit that you are going to go into detail. Like, hizi vitu zote we are talking about data science, we cannot look at them practically. The unit does not go that deep. Things like how to work with Python to implement intelligence, it is not practical. The unit does not avail for that. Okay, so we are just going to be studying how AI systems work, how they work. So that is your answer, Kimathi. We are not going to engage in practical sessions. Okay, as I said earlier, it's going to be a theoretical unit. It's going to be a theoretical unit. Okay, then, so I think we can stop at that so that I can also plan for another class, which is starting. So thanks for joining in the class, and also thanks for contributing and sharing your views and asking questions. So we will meet in the next class. Also, I want you to create a WhatsApp group. And Deritu John, I believe you are still the class rep, not unless walikutoa, but I believe you're still the class rep. So create a WhatsApp group and include all of us there.
Okay.
Yeah, so that we can work. It's already created, Collins. Someone says that it's already created.
You want one specific with you as a lecturer, as in for artificial intelligence?
Which one do you have? The one which you have is basically for.
We have one where we have added all the lecturers who are teaching us for this semester.
Yeah.
The one for DSC, year 3, Sem 1, that one.
Oh, yeah, that one. Oh, okay. Oh, it's the one. No.
Yeah.
You can work with that one. Let's work with that one.
Okay.
Yeah, let's work with that one.
All right.
Okay, then have a good day, all of you.